for the molecular dynamic calculation, the only thing that we should have is just recording a video and upload it in the YouTube, or there should be another results like density of states or something.
Yeah, thank you for the question. Today the whole lab will be to deal with these questions. So I'll answer now, but we will get back to it tomorrow in the lab. So in the VMD, there is an option to highlight specific bond between two atoms. As time passes by, it will show in your movie how the bond length changes over time. And you can explore if certain bond will break or form. So it is interesting chemical information. And some chemists plot total energy versus length of a bond, and they call it reaction coordinate. So it is interesting thing that you can try if you find it as needed. You can just qualitatively assess whether your molecule desorbs from the surface, or if new hydrogen bonds are forming between your amino acid and water. So just describe qualitatively what is happening. One option. And once again, nothing is mandatory. It's only as you see it as a researcher if it is important. Another thing which is a little more encouraged, I think it is here on this slide, after your dynamics is done, you can take the geometry after the dynamics, and for this modified geometry, run once again DOS and spectrum, and then compare how the thermal motion affected density of states and absorption spectrum. For some systems, it stays qualitatively the same, but for some systems, it makes drastic difference, especially if there are some bond breaking or bond formation events.
Yeah, I see. So the plotting, the DOS is the same, has the same process.
Right.
Okay. Thank you so much.
Yep, my pleasure. So I think it's more like evening of questions and answers. I see raised hand from Kia.
Yeah. So Professor, I'm worried about my model, because in my model atoms are for carbon 184, hydrogen 220. So it's less than 400. And I'm not sure that no, not less than 400, 400, more than 400, 404. So I'm worried that this MD analysis will be finished or not before submitting report, and
do not worry. First, there is in this little diagram that I'm showing, it doesn't tell for how long interval, how many time steps. Even if you pass like 100 femtoseconds, you still can characterize after that, right?
Yes. Yes.
And for your model, there will be expected, the band gap will become smaller, especially in the undocked model. It is expected. And by human eye, you will see that system will become more amorphous. So the in part it will be related to the questions that your advisor was asking originally about the dihedral angle. So during molecular dynamics, your strength of polymers will twist and bend and change geometry. Even if there will be no drastic changes, it is what happens in real life, and it could be quite interesting.
Okay.
On one hand. On another, which goes way beyond the material of this class, but let me attract the attention of those who are interested to do something more than in-class activity. The thermodynamics trajectory opens the door towards computing electron dynamics of electronic excitation dissipating energy into thermal vibration. So it is a way to compute non-adiabatic dynamics, non-adiabatic couplings that we discussed at the very beginning of the class.
Yep.
And those of you who will elect to continue computational research, after that, your molecular dynamics trajectories will be used afterwards.
Mm.
Whew. Any other questions? Question one, question two, question three. No questions. So I'm going to show two parts. First, what I will repeat what how to organize data and what can be placed as an objective data, excuse me, into written report, and then I'll give an overview of the text that you're going to write. Some of you are already experienced researchers and publicators. Some of you already have published papers, and it will be not interesting and boring for you. But for some of you, it will be new information, like how to organize written data, how to describe results of the research. And after the second part, I will show the templates that you will write about your classmates while reviewing works of each other. Okay.
Doctor, each student should review how many? Two.
And in some sense, it answers the question, how long should be report? It should be something that each of the class attendees can read and provide comments within 10 minutes, right? If some of you write too long report, then other classmate who will review it can write a comment. It's too long, I'm tired to reading it. It's so bad. So try to please each other, but its main idea of scientific publications, it's not for abstract reader, it's for humans, right, for humans. And if you keep in mind this idea, then your writing will be perfect. Okay, so select model, optimize geometry, make characterization, then hit molecular dynamics and characterize once again. And then you can compare the electronic properties before and after molecular dynamics. This 7 figures is a little too much, but you can take it as a template. So show geometry, table with geometries of several configurations, density of states of like before and after thermalization of fragments and hybrid. Then if you were changing number of electrons or number of unpaired spins, then it could be an additional figure. And let me ask permission of Lola. May I show your figure that you sent in the email? No answer. Let me formulate a different way. If you are against, if you do not allow me to show your figure, please speak. If you stay muted, I consider it as a permission. Okay, it seems Lola is permitting to show her figure. So she was looking for the total energy as function of number of electrons. And I'm not telling that everyone must do it. It's just an example of possible research. And there is a minimum for a certain number of electrons, which means oxidation. Typically, it is neutral. Maybe it's a little bit charged to the positive or negative. The total energy changes, and one can find the minimum, which means which oxidation state is most favorable. And if one finds like a minimum, which is different from neutral, it could be reasonable to explore density of states and absorbance at such minimum. And same, one can scan number of spin polarization, which I believe Steven is doing as a main part of his project, where spins are parallel and anti-parallel, and also show configurations for each of these configurations. Spectra, pairs of orbitals, either homo-lumo or those that provide maximal optical absorption, or those that show charge transfer if your project relates to photovoltaic. I think no one does photovoltaic this year. Molecular dynamics. If you have completed it, if you do see something interesting happening to your system, how to show molecular dynamics in the written report. So one can make screenshots, the image of your molecular dynamics at the beginning, in the middle, at the end. Like your trajectory is 100 or 200 steps, and you can show first, last, and one in between, and say it is what is happening to my system. And I assure you, for readers, it will be really interesting to watch it, to see in your paper what how temperature perturbs your system. Chat. It's noisy here. I'm sorry I didn't hear you on time. Okay, yeah, sorry for the noise. I hope the recordings will not have the noise, and I will try to share it tonight. Okay, and if I need to ask someone, I can duplicate the question in the chat line. Those of you who, if you see that snapshots of molecular dynamics drastically change your model, then it could be interesting. Again, it is not mandatory, but you can show how the total energy changes over time. And if by grep TT from the Aussie card, and if there is a breaking of the bond, then potential energy drops and kinetic energy drastically increases. So if you see energy over time changes, not oscillating as you may have seen before, not oscillating, but drastically changes by several electron volts, it could be a signature of chemical reaction, or it could be another way to watch to see chemical reaction. Okay, enough. Motivation. So we are not the first people on the globe who are writing written reports. In different cultures, different civilizations, public speaking and writing for community was quite popular. And I will show some examples from ancient Latin and Greek civilization, but there are examples in different parts of the world of ancient thinkers like 3, 4, 5,000 years ago who were giving some general ideas. So in this Western world, there was a general philosophical consideration how the public speaking or writing works, and just philosophically get through making plan of what you want to present, selecting style, then arranging your results and your logical steps that you want to present in the way that it will give the best effect. And then one can think whether one should attract attention by singing instead of speaking. So in modern world, we are not doing it. And if we do not have computers and pen and paper, how to memorize your own speech? So it's more ridiculous. It's more like fun. But the another part of Western civilization, ancient Rome, they were more practical than Greek, and instead of considering how it looks like by observing public speakers, the Romans were thinking about creating templates and practical recommendations how the ideal speech or ideal writing should look like. So let me ask if anyone in audience was taking Latin at any stage of education. Stephen?
Unfortunately, no.
Okay. Unfortunately, it's too small part of the semester left, so I cannot give you homework to learn Latin by next week. But if you are not, I also was not taking it, so if I pronounce it with errors, you will not catch me. So the three principles of public speech is delectare decere movere, which means to please, to communicate new information, and to urge audience to do something. So it's quite basic things, but if we discuss them right now, I feel it will be much more easier and pleasant for you to compose your brief reports. So just by human nature, anyone who reads your paper likes like jokes. If you are a please reader, humans by nature are curious. So if you communicate some interesting facts, you please the audience. And to move forward means you want the reviewer who will read your paper tell that it is the best paper of all times of nation and folks. So you want to impress, and you want the reviewer to declare that it is something really impressive. Okay, so from time to time, some class attendees have experience in Latin, and then I'm asking those to read, but I will try myself. At least I've learned from students from previous years. So the Cicero was one of the most successful public speakers, and he left some guidance what to write or what to say to follow these three principles. And he identifies several sections of any presentation. So basically, Cicero teaches us how to write report in computational chemistry class. So the first section sounds like exordium, and it means to catch attention, catch the eye of the reader from the first time, and prevent reader from falling asleep, from telling, oh, okay, it's a boring paper, I look for conclusions and write it negative report. So you need to attract attention and show that you are doing something interesting. Just that you're going to save the world, design a drug that will heal everyone, or give free energy, or make computers that will be million times more powerful than those we have today. Just impress with something, or just tell that there is a challenge that no one was able to solve, and we will try to do it. And maybe even summarize what was found in the work. So attract attention. Then the next section, narratio, which similar to English word narration. So it is summary of what other researchers have done if we are speaking about science, or if it is an ancient speaker who, for example, wants to protect the city from enemies, tells how the similar heroic feat was done in the far past, like telling what people were doing in similar cases. What is the statement of the case? And in our situation, it's more literature review and some references. Of course, we are limited in time. We cannot do dissertation, but you can insert 1 or 2 references, maybe 3, in your paper. Then the next one, partition or divisio, which sounds like partition function or splitting in parts or divide by parts. So if you are speaking, it's more like outline. If you are writing a book or thesis, it is table of contents. If it is brief writing or brief speech, you introducing which objects you are dealing with and which sections you will see, the reader will see in your work. So you are disclosing organization of your effort. And of course, one can do everything without it. But if you respect your reader and help the reader and reviewer to follow your logic and do it in an organized way, it is very much appreciated. So if in the career you will see that some people sometimes get negative reviews, and in most cases negative reviews come not because of the poor science but because of the not organized reports, because reader is getting tired of digging out what was finally the main idea. A lot of scientific writers do not pay attention to organization, and the reader needs to dig through and find what is the main message through the and finds it maybe only on the last page. So if you clearly describe how your paper is organized and where to expect what, like summary of methods, some objective results, discussion, just show what to expect. Proof of the case. So if the public speech is lawsuit speech of attorney, then it would be evidences, right? That the client is innocent. Or if it is a speech of persecutor, then it is evidences from the criminal is guilty. So some objective information that supports your main idea. If you're doing science, then it is some then it is your figures and tables, right? Objective information. And the little text that goes over your figures, like, summarizes them. Now, confirmatio. Yeah. The next part, confutatio, is the discussion. So when you are organizing your writing or preparing to speak in public, it is quite natural to accept the idea that not everyone in the audience, not each reader who opens your thesis will be 100% happy. If sometimes I think like, oh, those are evil people, they criticize me. But if you look objectively, it's not because the reviewers are evil people. It is because everyone, there is a diversity in opinions. They look on the problem different way, or they find the evidences that I provide insufficient. So there could be some criticism. And if I, as a writer, anticipate that the reader will argue with me, will disagree with some of my statements, I can prepare for it. So one of the best ways is I can try to be self-critical for a few minutes and find the weakest spot in my own work. And then I write it down and try to fight this criticism myself, to find the best answer to this criticism. So if I accept this game, rules of game, if I prepare for possible criticism and prepare answers ahead, there is a very high chance that I will catch what the reviewer will not like. And this argument can be, I shouldn't wait to give my argument after reviewer starts criticizing me. I can write it explicitly. Some of the readers may not believe this figure, but I know I used hybrid functional, which is known to predict band gaps, or just give argument that will beat potential criticism. So if you practice, if you think ahead, if you put this argumentation to defend your statements, it will be really pleasant writing that will win the brains and hearts of your reviewers, that you will be successful in moving in your audience, your reviewers, to do what you want them to do. Okay, and I'm not going to hide. It's not a part of my general education. I just read the statements from Wikipedia, but the last part of this suggestions from Cicero makes me to it's most funny, and it is inherited from ancient times. So it recommends that in peroratio, which conclusion, it's same like when one takes a tablet, take one tablet per mouth, that one should summarize arguments, blame anyone who disagrees, and induce positive feelings for the author, for the client, or for the case. This is more inherited from ancient lawsuits, or from making someone to vote the decision that you find reasonable for yourself. But you also can maybe borrow at least some inspiration from this idea. Please do not look at me. I am aware of these statements, but I fail all the time to follow them. So my lectures in public speaking are very far from this ideal, but maybe you'll do better and try to follow these guidelines. So if we translate the statements from ancient world to our modern world, we will have a little less sections. So instead of 6 sections, we can squeeze it into 4. And the first will be introduction, which may contain the following statements. So why the system you are studying is interesting. I'll give a reference. Then next sentence. Identify open problem for the system. Formulate a question. So it is completely okay to make up this sentence. As you were already obtaining some objective results, you can formulate your question based on your results, telling like, no one knew that spin-spin coupling will be positive in my case, or no one knows what will be spin-spin coupling. I'm talking about problem of that Steven is solving. What will be the sign in this material? But it is so important. Let's answer this question. Or it is completely unclear whether the peptide will bind to both surfaces. Let's answer this question. Or no one knew if conjugated polymers can conduct electricity. It's so important for technology that we should try to answer it by computation. So ask a question that is either challenge for technology or challenge for computation that is hard to do. Then Next thing, it is really healthy style of writing if you immediately provide a hypothetical answer. Of course, most of us are writing reports after results are done, and one can blend in your knowledge about the answer. But as in detective story, one should make an intrigue, and as in theorems in calculus, if you are taking courses of mathematical disciplines like calculus, differential equations, you probably noticed that all frequently they declare theorem main statement at the beginning and then spend another 2 hours to prove it. So you can immediately offer a hypothetical answer to your question, like for example, injecting electron or doping conjugated polymer should increase conductivity drastically. So it's answer that they will be conductors if one makes some manipulation with the structure. And then after you do this hypothetical answer, one can declare that through computational modeling, there are ways to prove this hypothetical answer right or wrong. So if you put the statements, there are chances that whoever reads your work will be happy. Then next is method, which would correspond to outline of major points, the divisio partitio. And in the ancient times, the logic was developed, but it was quite short logical connections, like connections between 2 or 3 statements, and it was not as developed as problematic to report methods. Now we have several concepts connected to each other as a train in the form of a chain, and we need to present methodology. And main goal for the methods section is to help reader to reproduce the results, or if we are considering this life in a scenic way, to make impression that the reader believes that he or she can reproduce results. So make an impression that you provide sufficient details for reproducing of results. Better if reader can, but at least main steps, main points. And here you typically place your equations and tell which software you use. As we discussed at the beginning of the meeting, try to match your figures and tables and equations in the method. Like show only those equations for which you show observables, for which you show results. So it should be consistent. Do not show results for which you do not show equations, and do not show equations for which you do not show results. Next, results and discussions. Tables and figures ideally should be multi-panel, right? So most of you have already developed so many panels, so many figures that they will immediately take like 20 or 40 pages. Try to select only most bright, most interesting ones. If there are homogeneous figures of the same nature, for example, several density of states, one can combine several panels into one super figure, multi-panel super figure. If you have several absorption lines, you can either put it multi-panel figure or find a way to plot several lines in one panel. So each figure should have should be described twice. First, in a brief form as a caption to the figure. Second, in a little bit more detailed form when you write your results in discussion. You tell figure 1 shows the model, and you can see that it is composed of 2 components. And then just briefly describe each figure, and basically help reader to understand what is computed, and since it is results in discussion, briefly explain why results look this way. For example, withdrawing An electron makes band gap 10 times smaller because the former HOMO becomes LUMO. I don't know if you buy this argument, but just very brief explanation as you can feed. And after you, and if you can put possible refutation of potential criticism, you can also put it here. But again, it should be brief report. Do not, it's not a thesis. And in conclusions, it is a really great step if you refer to your hypothetical answer. So if you make a logical step that based on the evidences provided in the results section, we can conclude that the hypothetical answer was correct. At the time when you write the introduction, you permit a chance that the evidences will be against your answer. But finally, when you prove it, you find, oh, okay, it's done. It's really as we hypothesized. And this looks like a little bit made up approach, but it takes into account human nature. If you make this little intrigue with hypothetical answer and proof, it is digested by human brains much easier than just boring list of facts and attempt to derive conclusions after. So this preliminary declaration of hypothetical answer helps reader to get through. And then also in the conclusions you can put things that may belong to discussion, convince reader that your results are valuable mostly as an impact for technology, and trustable, which means give some arguments why you believe the methodology you have chosen is applicable. And if there are references, they can be placed at the end. So a little bit of a little comment of the introduction. You all are developed researchers who selected graduate school as your career path, which means you have answered the motivation question for yourself a long time ago. But if this class would be offered for undergraduates who do not know what they want, in like at least 50%, or if you need to talk to general public, here I offer some silly logic why certain scientific research can be useful for what could be impact, what could be why can it be important for general public. So the research efforts that we do leads to publications and patents that are used in the industry, and then through industry one generates like energy and tools that regular citizens are using, and then they pay taxes to government, and government sponsors research. So in this path, science pleases general public citizens. Other way, the activity at research institutions trains future researchers, workforce who later enter industry and also go through fabrication of this energy and tools and some other things like drugs and whatever regular citizens need, and then it goes the same way. Or if you select academic career, the stuff that you are practicing in the class can be a development of educational materials that later on will be used in for teaching at colleges, and then later on can be increasing the literacy, general literacy of general public. I think you write something much better. It's a silly flow chart that just gives you an idea if you need to to start thinking or start moving how to explain your motivation. So don't forget discussion. It's natural part of scientific life. So review criteria. Each reviewer will get a copy of the reviewer's form and will be asked to fill it. So you read a paper and you fill a form. The statements in the form are borrowed from not from one journal, but from several journals, basically from American Chemical Society. And I'm going to overview what are these statements that you as reviewers are expected to fill. So in regular research life, which we try to mimic, there are very unlike chances that the paper is recommended to reject and very unlike chances that paper is accepted as is. Most typically, there are recommendations either to publish after major revision or after minor revision. So it's like 90% of cases. In most of journals, so it works this way. You submit the paper to the journal and it is processed by editor-in-chief and the assistants, editorial assistants. And then they forward it to reviewers. And reviewers get pressure from editor to be critical and to answer certain questions, which slightly vary from journal to journal. And common question is to summarize what paper is about. So if, as reviewers, you summarize in like 10 words what is the main result of the paper, it will be very helpful information for the author. So some of you, as some of us, as kids, were playing a game of broken telephone. Did you? So it's like several kids sit nearby in a circle, whisper one statement to the ear of the neighbor, and then he or she whispers it to the next ear. And when the information passes through the circle, it's completely modified. It's very different from what originally was. So even with two chains, it can be deformed. And if reviewer writes what he or she understood about this paper, and author can be really surprised how the reader interpreted what the author has composed. And this statement will help author to modify the final draft to be more understandable by others. Some forget to put title, author, and address. Do not put your home address. Put NDSU like. But it's a standard practice in the community. Introduction. Is there a big picture? Like, is there motivation, importance, motivation to focus on this topic, other references, and other challenges. So if the author writes open questions and challenges, reviewer should give a credit to the author and mention, is it hypothesis-driven research? Which is very, so the stuff about hypothesis that we were discussing a few slides ago here is very much appreciated, not only in journals, but also in funding agencies who support research with funds. So there are two good words that one may say about someone else's research to promote it. So you can say that it is a hypothesis-driven research, and you can say that it is transformative. So if there is a hypothesis, you can reviewers may try to reproduce hypothesis. Another question: which audience the paper targets? Is it only specialists, or it will be interesting for general public, or for undergraduate students, or for high school students? The broader the public, the better the paper. You know that most cited and most important scientific papers are like Nature and Science are published for broad audience so that everyone can understand. Figures. Years ago, computers were not as spread, and journals were published in paper, and sometimes copied in black and white. So if lines are not thick and visible, it will be not possible to recognize what is done. So give credit for thick lines if you see if they just distinguishable. Check if there are labels, and check as reviewers if there are captions. So each figure should have caption. It's standard in the community. If it is, if it doesn't have captions, complain or criticize the reviewer. Also criticize if something is not clear. Logical organization. Just if you see logics, if the text that describes figures one after another is something that flows from one statement to another. There is a common error of beginner writers to just throw together all information without connecting it to each other. Just here are all my figures, enjoy whatever you understand in them. So try to make connection. For example, if one in figure 2 we see that band gap is 3 electron volt, therefore in figure 3 the absorption starts at 3 electron volt. It's not a big discovery, but it makes it more continuous. As reviewers, you can recommend to author that some parts are swapped in orders shorter or extended, especially if someone in class tries to write a dissertation 50 pages long. Tell it, I do not have time, I need to finish review in 10 minutes, so please try to be shorter next time. Or if it is like, if you see someone wrote 1 or 2 pages, they're like, in this short, I cannot understand whether there is any scientific value. Please expand the explanation. Conclusions. So if do conclusions refer back to challenge and hypothesis from the introduction? Is there new knowledge you as a reader, as a reviewer found in this work? Is there something the reviewer wants to borrow from the paper? And also the strongest impression that reviewer can give about a paper is an impression of healthy jealous. Like tell, oh, why didn't I do this project? It's so interesting. I see so many new things. Why didn't I start doing it myself? So if a reviewer writes this way, it means it is something really, really precious. Or if you want to support a paper, write like this. So which statements from conclusions can inspire you to run a similar type of research? Do authors tell how they want to continue? Is it interesting for general public? And let me add a new thing. Is there a comparison of P, B, E? It is a keyword question. And HSE 06. So for educational purposes, it is not as important. But I remember from previous years, during the time of at a time of presentations, there were visitors who were asking this question to everyone in the class. And I was trying to protect class attendees, telling that it is not so important, it was not part of the class, but this question could be asked. And you may either prepare how to answer it without additional calculations, or you may plan to do additional calculations. You're not doing for me. I will give you excellent reports based on what you already did. I like hope you did everything well. But if you want to refute possible criticism of reviewers, of not reviewers, no, the visitors. Everything we did here in class was done with exchange with DFT, exchange correlation, GGA functional, PBE. But there is a class of hybrid functionals, and one of them is HSE, which gives a little bit better bandgap energy. So if you look into the binary in-car directory, there will be in-car underscore HSE, and if you use it, it will generate results that would satisfy this potential criticism. I am not demanding. It's not mandatory for the class, and HSC calculation will be 40 to 100 times longer. So it's more expensive calculation, although it is DFT as well. But just be aware that such question may appear. Lola and Steven are aware that, especially if you do things in Gaussian, one can screen several functionals, and it is a question that community sometimes is getting interested. So it was a side notice. Results and discussion. Results clearly presented. All written statements supported by presented data. And can reader see mechanisms of elementary processes? So elementary processes are, for example, electron promotion from occupied to unoccupied when you photo excite, or it can be spin flip that you model, or it can be adsorption, desorption. It's like elementary process. So if the author makes an attempt to dissect observations onto some mechanisms of processes, give a plus, give a credit to the author. Number, quality of figures, tables appropriate. So if there are too many or too few figures, complain. If figures are not explained in the free text, complain. Methods. Which equations were numerically solved? We discussed it at the beginning. So Consham self-consistent equations and equations for observables like DOS and absorption. Ideally, each term in equation should be explained. So if it is not, complain. Another question that we kind of left free, but very critical audience very critical reviewer may ask a question: why the author select certain method? For example, why you use DFT rather than molecular dynamics, force field molecular dynamics? And the answer is that force field doesn't allow bond breaking and bond formation. I'm just giving an example. Or why you do absorption spectra with DFT rather than TDDFT? And the answer is that TDDFT is of course more precise, but it takes longer time to compute and takes only a smaller system. So the question, the origin of this question, not about specific method and specific selection. It's more about to see that the author makes an effort, intellectual effort to select the best method, and the author recognizes that there are several methods to solve this and that problem. Methods trustable? I hope yes, but also you can practice critical thinking. And if the methods are incomplete, what reader needs, what else reader may want from explanation? Just if you see that something is not clear, you can try to complain. Okay. So we are a little bit quicker than in previous years. So I think it was meeting number 29. So I'm done. Everyone is welcome to disconnect, but I'll stay here to answer any questions.